Good morning everybody. Myself Acharya Vishvendra, and today I shall be working on modern physics. It's a complete video lectures so that you can optimize your time and energy. So let's begin with the modern physics itself. So the first chapter here is dual nature of radiations and matter. It is composed of 4 topics. The first is introduction, second is quantum theory of light, third is photoelectric effect, and fourth is matter waves. So let's start with the introduction. So initially light was supposed to be a particle or a corpuscle as proposed by corpuscular theory of light, which was proposed by Descartes and further developed by Isaac Newton in his book Optics. The first thing about this is then we have second thing, light as a wave or the wave theory of light. It was originally proposed by Christian Huygens, but it was experimentally proved in 1801 by Young's double slit experiment that light has wave nature. Third aspect is the quanta or photon nature of light, which was proposed by Albert Einstein and Max Planck as well. But Albert Einstein was more concerned about light, the quantas of light, whereas Max Planck was working on a general concept of electromagnetic waves and treating them in the quantum picture of light. So using the quantum theory of light, Albert Einstein explained the photoelectric effect in 1905 and got Nobel Prize in 1921 for the explanation of photoelectric effect and theoretical physics. So this is a brief introduction regarding this. So compiling all these 3 aspects, we can say that light has dual nature. It can behave as a particle as well as a wave depending on the extreme or external conditions or experimental conditions. So that is regarding the introduction. Now let's begin with the quantum theory of light. According to this theory, light is made up of discrete particles or packets of energy called as photons. Suppose this is source of light, it is emitting light. So consider one of the photon or particle or packet of energy which we call as the quanta. Now there are certain points regarding the quantas. First is rest mass of photon is 0. Photons are neutral, so they are not affected by electric and magnetic field. Next thing is photons carry energy and momentum and can transfer them to matter by interacting with them in a collision. Next is in a collision between photon and particle, total momentum and total energy remains conserved, whereas number of photons are not conserved. New photons may be created or old photons or photons may be destroyed. So here it should be noted that number of photons are not conserved in collision between photon and particle. Next is the energy of a photon is related to its frequency by the relation E is equal to h into nu, where E is the energy, h is the Planck's constant, and nu is the frequency of light. Now next is the values of H are 6.6 into 10 is to power minus 34 joule second, and it is also equivalent to 4.14 into 10 is to power minus 15 electron volt second. Then SI unit is kg meter square second minus 1, CGS unit gram centimeter square second minus 1. It can be observed from here, and dimensions are M1 L2 T minus 1. Now there is a question, we are being given frequency, we need to find energy in joule. So energy is h into nu, substituting the value we get this as energy, and in electron volt we get this as energy. Next point is all photons travel with the speed of light in vacuum, which is maximum possible speed of photons. Next is in a medium, photon having large wavelength or a smaller frequency travel faster. So out of waveguide in a medium, red travels fastest and violet travels the slowest in a medium. Whereas in vacuum, all colors travel with the same speed. Next question is, in vacuums, all colors travel with same speed, as I said earlier. It has been asked in a PYQ. Next is speed of photon in vacuum is related to its wavelength and frequency by the relation C is equals to lambda into nu. It's a very basic relation between wavelength, frequency and speed of any wave. So if we refer to the vacuum, then we can refer to this thing. Next is, if medium is same, then we can say that wavelength is inversely proportional to frequency. So if frequency increases, wavelength decreases, and vice versa. So if we draw the graphs between frequency and wavelength, the graph is going to be a rectangular hyperbola with 1 by v a straight line. If we draw graph between c, as c is constant, so that will be like this. With the lambda again, graph will be like this. Next is product of lambda v is constant, so graph will be like this. So we have all the possible graphs over here. Next is momentum of photon is related to energy by the relation P is equal to E by C, which is h nu by C. So if we draw the graph between P and V, we can P and nu, so we can say that it is a straight line. And if energy increases, so you can say that graph is a straight line, and then tan theta here is h by c, as we can draw the graph over here. Next is, now P is equal to h nu by c. So substituting the value, we have P as h by lambda, or P is equal to h by lambda. So if we draw the graph between P and lambda, that will be rectangular hyperbola, and graph between P and 1 by lambda will be a straight line. From here, the inverse relation is there, so we can say that on increasing momentum, lambda decreases, and on lambda increases, P decreases, because they are in inverse ratio. So we can just say that. Next is, let's analyze the spectrum of Vibgyor. So as we move from violet to red, lambda speed in vacuum, speed in medium increases, whereas frequency, energy, momentum and mass decreases if we go down from violet to the red end. Whereas if we go from red to violet, then lambda decreases, frequency increases, energy increases, speed in medium decreases, momentum increases, mass increases. So as Vibgyor is concerned, we can say that lambda and speed in medium are maximum for red color and minimum for violet, whereas frequency, energy, momentum and mass, these are maximum for violet and minimum for red. So we can analyze that out of Vibgyor, wavelength and speed in medium is maximum for red and minimum for violet, whereas frequency, energy, momentum and mass are maximum for violet and minimum for red. Next is, energy of a photon is related to its mass by the relation E is equal to mc square. So the graph between E and m will be a straight line. If slope angle is theta, we can say tan theta is E by m, which will be equal to c square. Now momentum is E by c, so we can say that momentum is equal to m into c. This is momentum in vacuum. So we can say that P is proportional to m, the graph will be a straight line. And if we find the slope angle, that will be P by m, so on solving we get that as c. Now there is a question on that. A photon has a frequency this. We need to find energy of photon in joule, energy in electron volt, speed of photon in vacuum, wavelength of photon, momentum, mass. The photon travels with its speed in this, then wavelength change. So we use E is equal to h nu, substituting values we get energy in both the cases, in joule and in electron volt. Then we know that in vacuum photons travel with the speed of light, so that is relation over here. Next is, we can find lambda, we can find P, we can find mass. So if photon travels, then will frequency change? No, as frequency is dependent on the source itself. Next is, will the wavelength change? Yes, wavelength depends on the medium, so it will change. Next, now we have a question. Energy is given as 3 electron volt over here and we need to find energy in joule, speed of photon in vacuum, frequency, wavelength, momentum and mass. So we know that E is equal to h nu, we can find this. Then we know in vacuum speed is this. Then frequency can we find as c by lambda equation. Then we can find lambda from this equation. Then we can find momentum from this. Then we can find mass from P is equal to mc. There is another question here. Wavelength is given, we need to find speed in vacuum, frequency, energy, EV, momentum and mass. So we know that speed is this 3 into 10 is to power 8. Frequency is c by lambda, that will be the frequency. Energy is h into nu, we can find the energy like this. Then in electron volt we use h as 4.14 into 10 is to power minus 14. Then we have momentum is equal to E by C, so this can be the momentum. In this way we can solve the question. Now there is another question in which wavelength is 100 nm, then find its wavelength in meter, angstrom, electron volts, joule, etc. So we can say that lambda in meter will be this, in angstrom will be this, energy is hc by lambda. Solving equation we can find E. Then using h in electron volt we can find energy in electron volt. Then we have frequency, so frequency is given by this relation. We can find the frequency by using the equation that frequency is c by lambda. Then we have mass is p is equal to mc, we can find the mass. Then we can find the momentum as e by c, so we can find the momentum. There is another question, when electron is accelerated we need to find kinetic energy in ev, kinetic energy in joule, maximum kinetic energy of X-ray photon when this electron collides with crystal, maximum frequency, wavelength, momentum and mass. So it can also be solved by using energy as here it is 3 volt, so the energy will be 3 electron volt here, and you can convert those things into the parameters. Next one now, so these were certain questions. This is a very first part of the topic. So soon I'll be uploading the second part. So these video lectures are a complete package for JEE Main and NEET Physics. So these will just optimize your time and energy and help you get optimal results in the exam. Thank you and have a nice day.